Have you ever wondered how a barren, fiery rock, floating in the vast emptiness of space, became the cradle of life? A planet pulsing with creatures, colors, and consciousness. Tonight, dear curious explorer, welcome to the Sleepless Scientist, where we chase the mysteries of the cosmos. Wide-eyed and wondering, long into the night, you've stayed up late, fueled by questions. And now, it's time to dive deep, to unravel the epic tale of how life, yes, life began on our little blue world. So, grab a cozy blanket, settle into your favorite chair, or gaze out at the stars from wherever you are. I'd love to know, where are you tuning in from tonight? What time is it in your corner of this spinning globe? Drop it in the comments if you're feeling chatty. It's always thrilling to see how far our sleepless ship sails. And if this journey sparks your curiosity, a quick tap on the like button or a subscription keeps our quest alive, like a jolt of energy to the engines of discovery. Gentle nudge, much appreciated. Now, let's not get too comfortable just yet. The story of life's formation on Earth is no sleepy bedtime tale. It's a saga of chaos and calm, of molten rock and gentle waters, of chemicals dancing in a cosmic brew. Don't worry, we're not here to drown you in jargon or race through formulas. Instead, picture this: a young Earth, wild and untamed, cooling from a fiery birth, setting the stage for something miraculous. Ready, take a deep breath, let your mind wander, and join me as we chase the origins of life itself. Imagine, if you will, a time over 5 billion years ago. The universe, still young, is a theater of violence, stars exploding, gas clouds collapsing, and rocky debris smashing together. Our Earth forms from this cosmic chaos, a molten ball of lava and dust, born in a swirling disk around a newborn Sunday. This is the Hadean Eon, a name that whispers of hellfire and fury. The planet's surface is a sea of magma, glowing red and raging, bombarded by meteors and comets like a cosmic firing squad. Temperatures soar, hotter than any oven, melting rock into liquid fury. Gravity, that patient sculptor, pulls the heavier elements iron, nickel down to form Earth's core, while lighter materials rise, crafting a primitive crust. But amidst this inferno, something remarkable brews. Those crashing comets and asteroids, they're not just agents of destruction, they're cosmic couriers, delivering water, carbon, and other building blocks, perhaps the very seeds of life. Scientists call this period the Late Heavy Bombardment, a reign of chaos that pummels Earth for millions of years. Yet, as the planet cools, steam rises, condensing into clouds. The skies darken, and the first rains fall, torrents that last for centuries, infilling basins to form the earliest oceans. Picture it: a young Earth, still steaming. Its surface, a patchwork of scalding rock and newborn seas, quietly preparing for a miracle. Fast forward to about 4 billion years ago. The Earth has calmed just a little. The Hadean Eon fades, giving way to the Archean Eon, a time of transformation. The oceans are now vast, warm, and rich with chemicals: carbon, hydrogen, oxygen, nitrogen, and more dissolved from the air and leached from the rocks. This is the primordial soup, A cosmic kitchen where the ingredients of life begin to simmer. But how do simple chemicals leap to the complexity of life? That's the question that keeps scientists up at night. And tonight, we're joining them. One theory, the primordial soup hypothesis, suggests that in these warm, shallow waters, or perhaps near hydrothermal vents, those fiery underwater geysers molecules start to dance. Energy surges in lightning, crackles through the sky. Ultraviolet rays from the young sunday pierce the atmosphere, and volcanic heat bubbles from the depths. In 1953, a sleepless scientist named Stanley Miller, alongside Harold Urey, tried to recreate this ancient recipe. They mixed water, methane, ammonia, and hydrogen gases thought to mimic Earth's early atmosphere, zapped it with electric sparks, and watched in awe. Amino acids, the building blocks of proteins, emerged from the broth. It was a spark of insight, a hint that life's recipe might have started here, in this chemical cauldron. But the soup isn't the only chef. Deep beneath the waves, hydrothermal vents spew heat and minerals, creating oases in the dark. The vent hypothesis whispers of life, beginning in these hidden realms, where chemistry thrives in extreme heat and pressure. Molecules like methane and hydrogen sulfide collide, fueled by the Earth's inner fire, forming chains, perhaps the first steps toward life. It's like a cosmic pressure cooker, patient and persistent, cooking something extraordinary. Now, let's zoom in. We've got amino acids, sugars, and other simple molecules floating in the soup or bubbling at the vents. But life needs more. It needs complexity, structure, a spark of organization. Enter the molecules of potential nucleotides, the units of DNA and RNA, the carriers of genetic code, RNAA, a simpler cousin of DNA. Might be the star of this chapter. The RNA world hypothesis argues that RNA, versatile and clever, could both store information and catalyze reactions, like a cosmic multi-tool. In warm pools or on mineral surfaces, clay, perhaps. Acting as a scaffold, these molecules link up, forming chains, folding, experimenting. But how do they stick together? Picture tidal pools along ancient shores, where water evaporates under the sun, concentrating chemicals like a chef reducing a sauce. Or imagine deep sea vents, where minerals cradle these fragile chains, shielding them from the harsh world. Energy keeps flowing solar, thermal, electric driving reactions forward, slowly, over millions of years. These chains grow, replicate, and stumble towards self-sufficiency. They're not alive yet. Not quite. But they're flirting with the edge, like a spark waiting to catch fire. And then, a breakthrough, a protocell forms, a fatty molecule. A lipid naturally shapes a bubble, a membrane, trapping these active chains inside. This is the dawn of separation, a tiny fortress against the chaos outside. Inside this bubble, molécules replicate, react, and evolve. It's not life as we know it, but it's a whisper of possibility. A quiet rebel in a restless world. What is life? Exactly. Scientists wrestle with this late into the night. It's a system that metabolizes, uses energy, replicates, and evolves around dry 8 billion years ago, or perhaps earlier. These protocells cross the line. They harness energy, maybe from chemicals in the vents, or sunlight in the shallows, breaking down molecules to power their work. They copy themselves imperfectly, allowing variation mistakes that fuel evolution. These are the pioneers, the first microbes, single-celled and simple, yet revolutionary. Fossils whisper of their presence. In rocks from Western Australia, San, 5 billion years old, we find traces stromatolites, layered mounds built by ancient bacteria, cyanobacteria. Tiny powerhouses emerge, using sunlight to turn water and carbon dioxide into oxygen and food. This is photosynthesis, a game changer. Slowly, oxygen seeps into the oceans, then the air, transforming Earth. The planet breathes, its atmosphere shifting from harsh and unbreathable to life-friendly. These microbes, quiet and unseen, are the architects of our world, sculpting a stage for all that follows. But life's early days are fragile. The Earth still rages, volcanoes erupt, meteors strike, oceans boil. Yet these tiny pioneers endure, clinging to cracks, thriving in the dark, adapting. They're the sleepless survivors, relentless in their quest to exist. Now the stage is set. Single-celled life rules for billions of years. A quiet dynasty of microbes. But around 2 billion years ago, something stirs. Cells begin to team up. One bacterium swallows another. But instead of destruction, they strike a deal. The swallowed cell becomes a powerhouse mitochondria, fueling its host with energy. This is endosymbiosis, a cosmic partnership that paves the way for complexity. Fast forward to 600 million years ago. The Ediacaran period. Life diversifies. Soft-bodied creatures strange, frond-like, alien, crawl through the oceans. Then, the Cambrian Explosion. A burst of innovation. Around 540 million years ago, shells, skeletons, eyes, and limbs appear. A carnival of forms. Trilobites scuttle, worms burrow, and predators prowl. Life, once a whisper, now roars still quiet in its way, but vibrant, varied, unstoppable. What drives this leap? Oxygen levels rise. Thanks to those ancient cyanobacteria, the oceans stabilize. Nutrients flow, and evolution experiments wildly. Each step builds on the last. A slow climb from single cells to the edge of consciousness. Life, born in chaos, finds balance, weaving a tapestry across the earth. And here we stand, dear curious explorer, at the edge of an epic tale. A journey spanning 5 billion years, from a molten, fiery rock to a vibrant, breathing planet teeming with life. Welcome back to the Sleepless Scientist, where we chase the universe's deepest mysteries. Eyes wide open, hearts racing with wonder. You've traveled with me through the chaos of Earth's fiery birth, the simmering of the primordial soup, the first fragile sparks of microbes, and the dazzling explosion of complex creatures. Now, as you settle into your cozy nook, perhaps wrapped in a blanket, gazing at the stars, or sipping a late-night tea, let's linger here. At the crossroads of the past and the future, I'd love to know, where are you tuning in from tonight? Is it a quiet evening? A restless midnight? Or a dawn just breaking? Drop it in the comments if you're so inclined. It's a thrill to see how far our sleepless ship sails across this spinning globe. Take a deep breath. Let your mind stretch across time. We've seen life rise from a barren earth, stardust forged in ancient stars, stirred in chemical brews, shaped by eons of trial and error. But this isn't just a story of the past. It's a living legacy, one that pulses in every cell, every breath, every heartbeat yours. Mine, the rustling leaves outside, the distant cry of a night owl. And it's a story still unfolding. A cosmic question that keeps us awake. What does the future hold for life? Here on Earth and beyond. Let's dive in, wide-eyed and wondering, to explore the legacy of life's formation and the tantalizing possibilities that lie ahead. Picture this: 5 billion years ago, Earth was a hostile infant, scorching, chaotic, pummeled by cosmic debris. Yet, from that turmoil, life emerged, tenacious, inventive, relentless. Those first microbes, barely more than chemical whispers, clung to existence in steaming oceans and volcanic vents. They harnessed energy from sunlight and chemicals, replicated with tiny imperfections, and set the stage for evolution's grand dance. Cyanobacteria. Those quiet heroes flooded the air with oxygen, painting the skies blue and building a world where we could breathe. Over billions of years, life wove a tapestry. Single cells joined forces, forming partnerships like mitochondria, giving rise to complex creatures. The Cambrian Explosion, 540 million years ago, unleashed a carnival of forms: trilobites, worms, predators, all tracing back to that primal spark. You and I, dear explorer, are part of this legacy. The carbon in your bones, the water in your veins, the oxygen you inhale, it's all stardust, born in the hearts of ancient stars, delivered by comets, stirred in Earth's early cauldron. Scientists call this panspermia when they ponder if life seeds drifted here from elsewhere, or abiogenesis when they trace it to Earth's own chemistry. Either way, we're connected to the cosmos, a living bridge between the Big Bang and today. Look outside. See the trees swaying, the insects buzzing, the clouds drifting, every blade of grass. Every creature carries this 5 billion year story. It's humbling. Isn't it a quiet marvel that keeps us up at night, wondering how a rocky planet became a cradle of consciousness? Life's legacy isn't just biological, it's geological. Too, those early microbes reshaped Earth itself. Oxygen from photosynthesis oxidized iron in the oceans, painting rocks red in banded iron formations. Relics we find in places like Australia and Canada, 3 to 2 billion years old. Stromatolites, layered mounds built by ancient bacteria, dot the fossil record, whispering of life's tenacity. The atmosphere shifted from a harsh mix of methane and ammonia to one rich in oxygen, a silent revolution that paved the way for animals. For us, life and Earth grew together, a cosmic duet, each shaping the other. It's like a patient gardener and a willing soil, coaxing miracles from chaos. But life's story isn't static, it's a restless, evolving saga. Today, Earth pulses with diversity, millions of species, from deep-sea fish to mountain goats, from fungi to forests. Evolution, that tireless tinkerer, drives this change. Natural selection, genetic drift, and mutation tweak life's code, adapting it to shifting climates, quaking continents, and sudden disasters. Think of the dinosaurs, ruling for millions of years, only to vanish 66 million years ago when a meteor struck, dusting the skies and chilling the planet. Yet, from that chaos, mammals rose, small and scrappy, leading to us sleepless dreamers who ponder our origins. Humans, too, are agents of change. We've tamed fire, built cities, and altered landscapes. Our footprints, our vast agriculture, feeds billions. But deforestation and industry shift the balance. Carbon dioxide, a gas life once balanced, now climbs, warming the planet. Scientists watch, wide awake, tracking rising seas, shifting weather, and species on the brink. The Anthropocene. They call this era a time when humans sculpt Earth's future. It's a weighty legacy. Will we be wise stewards or reckless disruptors? The question lingers. A spark of curiosity that fuels late-night debates. Life adapts, as it always has. But its pace races against our impact. Microbes evolve resistance to drugs. Animals shift ranges. Life's resilience shines. A quiet strength in a changing world. What lies ahead for life here? Let's gaze forward. Eyes bright with wonder. Climate change challenges us. Temperatures climb. Oceans acidify. Habitats shift. Yet, life's history whispers hope. It survived ice ages, volcanic eruptions, mass extinction. Scientists predict species will adapt, some thrive, like hardy weeds or heat-loving microbes, while others fade. Genetic engineering, a human innovation, might help imagine crops that withstand drought, or corals bred to endure warmer seas. We're learning, sleepless and determined, to mend our impact, to harness solar and wind, to restore forests, life and earth, partners for eons, may yet find balance. But the future isn't certain. Catastrophe loom asteroids, supervolcanoes, or our own missteps. If we falter, life won't kit. Cockroaches, tardigrades. Tough survivors might carry the torch, rebuilding in the ruins. Billions of years from now, the sun will swell, a red giant, scorching Earth. Yet, life's tenacity might linger. Microbes hiding in deep cracks, a final echo of our planet's pulse. It's a humbling thought. We're a chapter, not the end. Life, that restless explorer, presses on, adapting, enduring, a cosmic flame that refuses to flicker out. Now, let's stretch our minds further, to the stars. If life began here, could it spark elsewhere? The question burns. And keeping us awake, Mars, with its ancient riverbeds, hints at past waters. Perhaps microbes once thrived, or still hide beneath the dust. Europa, a moon of Jupiter, conceals an ocean under ice. Warmed by tidal forces, could life swim there? Simple and strange, Enceladus, Saturn's icy game, spews water plumes, rich with chemicals. Astrobiologists, sleepless with excitement, hunt for signs, biosignatures like methane, oxygen, or alien molecules. Panspermia whispers another tale. Did life seeds drift across space, hitching rides on comets, landing on Earth, Mars, or beyond? Or does abiogenesis spark uniquely? Each world a new cauldron, exoplanets. Thousands dot the galaxy beckon. Some orbit in the habitable zone, the Goldilocks region. Not too hot, not too cold, just right for liquid water. Telescopes like James Webb peer out, seeking hints, water, vapor, atmospheres, signs of life. Imagine a planet pulsing with alien forests, oceans, or minds. Are we alone? Or part of a cosmic choir? The question dances, a mystery that fuels our sleepless nights. And what of us, humans, born of Earth's legacy, might carry life outward? We dream of colonies on Mars, bases on the moon, ships to the stars. Microbes from Earth could seed new worlds, intentionally or by accident, sparking alien evolutions. We'd be cosmic gardeners, spreading life's spark. But caution lingers, will we disrupt or create? The future stretches vast, a canvas of possibility, painted by gravity, chemistry, and our daring. So, here, we pause. 5 billion years from Earth's fiery dawn, life's journey from chemical whispers to conscious dreamers is a marvel. A legacy of resilience, adaptation, and wonder. You and I, the trees, the oceans, the stars above, were woven from the same cosmic thread, a story of stardust and struggle. The future beckons, uncertain, but alive, on Earth and beyond. Will life endure our changes, seed new worlds, or fade into silence? These questions, dear explorer, keep us sleepless, eyes on the stars, minds racing with possibility. Where are you tonight? Is it a late hour, a dawn, or a moment stolen under a twinkling sky? Tell me, where are you? What time is it? If this journey through life's legacy has stirred your wonder, a like or subscription fuels the Sleepless Scientist, a burst of energy to our questing ship. I hope this tale lights your curiosity. Not too much to banish sleep, but enough to spark dreams of cosmic origins. Until next time, stay restless, gaze upward, and chase the mysteries of life here, there, and everywhere. Dream deeply, dear traveler, of stars, cells, and the endless rise of existence